progress.
Okay, as we discussed yesterday, we will cover Kubernetes, okay, the hard way. So, Kubernetes. Hard way means we have the, uh, you know, manage the master part and worker part, okay, in this case. So, previously we go with the self-managed one, right? To manage the Kubernetes by cloud provider like EKS. So, the coming to the managed Kubernetes, the AWS cloud provider will managing Kubernetes, this EKS Kubernetes master part components. Okay. And we only define how much machine we need like that. We need to define. So it will create a Kubernetes cluster like with the desired node. For example, two node, right? So we got two node and there is a master part there, but it's managed by AWS. Also in this case, AWS load balancer there. If you need a load balancer, AWS will automatically create a load balancer. Then for patching, okay, patching of this machine. So that managed by AWS provider. So I mean, managing the nodes, managing node. So coming to self-hosted, now we are going to learn and test a lab about self-hosted Kubernetes cluster. Okay, the hard way. So self-hosted. Self-hosted means we have to install manually all of these components or the entire cluster. Like coming to the master part, we need to install the master part component and the node, we need to configure node. Then we need to join that node to master part. So for that, we can do the same lab in our using our laptop. Okay, for example, if we have two machines in our local premise, so we can set up a Kubernetes cluster with that machine as well. Like one laptop, we have another laptop. Okay, there is two laptop or a personal machine. That's fine. So we need to install the master part component on the first machine. So this will be your first laptop, and we will make the second laptop as one of our worker node. So this will be the worker, and this will be the master. And also we can if we install all of the components here, we can see this is a local Kubernetes cluster. Also we can deploy application. So today we will do leveraging two virtual machine. Okay, virtual machine in EC2. Sorry, EC2 machines. We're using EC2 in another place. And also for bootstrapping self-hosted Kubernetes cluster. Okay, self-hosted cluster. We leveraging one tool. That tool name is called Kubernetes. So using this Kubernetes tool, we can easily bootstrapping Kubernetes. So it's a very useful tool. It's a production ready tool actually. Coming to production environment, we mostly using Kubernetes to bootstrapping Kubernetes cluster. So we can jump into the lab, right? So one more thing, coming to the cost comparison, okay, self-hosted. When comparing with the managed one, self-hosted is much cheaper, okay, because managed Kubernetes cluster taking too much charge. For coming, if we, uh, for example, and where we actually using self-hosted for development phase, it's good. I mean, dev stages, okay, so we can use or implement self-hosted. For the production, mostly we go with the managed one. One more thing we need to do before spinning up that machine, okay? That is actually, there is some ports there. So we need to open the ports correspondingly. I will show the port number. See, this is a port number, okay, for the entire services. So we need to open. First, we will, in this case, we will using two machine, okay? So for what we make one as master node and second one is our worker node. So for the master node, we need to open the port number starting with the 1 to 7. And for the worker, we need to open port number 1 to 4. Good. So coming to first port TCP 6443. So that port's actually using for Kubernetes API server. Got it. So all that API requests go through the port number 6443. Then for etcd, we need to open 2379 and 238. 380. Okay, two port we need to open for etcd. These all come under the master part. Okay. Then kubelet API. We need to open 10250. Kubelet API is agent, right? The agent that running on master node. Sorry, worker node. So here you can see coming to worker node, same port number opened. Then kube scheduler and kube controller, we need to open 259, 257. Then SSH 22 for the SSH. And UDP 8472. This is for cluster-wide network communication. Flannel. This Flannel means it's a service actually, okay, for setting network within our cluster. So that's all the ports. Like, these all the ports we need to open, okay, before configuring the machine or after, fine. Then coming to worker node, we need to open the same kubelet API. We need to open not port service. We need to open. Okay, then SSH and UDP. So here you can see not port services. That's starting with the 30,000 and 32,767. So around 2,000 something port we opened for not port service. Not port service means service expose. I mean application. You need to expose the application, right? So this port actually using. So we can deploy around this much application. For example, if we deploy one application, okay, how we will access using the port number. One of the port number in between 30,000 to 32,000 something. Also using the IP of that worker node. Got it, all of you. So in
Notepad
my
is
case,
something which we will be.
hmm, it's a service actually, Kubernetes service. The
We'll be
kind, not
accessing that. Oh, echo is
sorry.
coming. IP within the EC2 instance, right? Outside of the Kubernetes cluster, but within the EC2 instance.
Right, right.
It cannot be accessed out of like if
No,
you are
no, no,
doing
no, no.
it, I can't access that one, right?
Give me a second, I will show you. So, okay. So finally, we will deploy the, bootstrapping the Kubernetes, right? Using KubeADM. So we will get one master node and the worker node. So we have one node here, okay? And we deploy some application. So this is the pod. Application container also running inside. It's container there. So we need to expose this application, right? For example, write a YAML file, right? And we define the kind as deployment. That's all. For exposing this, we need to set up a service for the same, right? So we need to write another YAML file, or else we can include that service definition in the same YAML file. So we create another service YAML file and defined the kind is service. And coming to the bottom, we can see the type, service type.
Load balance.
So if the service type
Sorry.
is cluster IP,
Cluster IP. Okay.
that means the specific application accessible inside the cluster
Cluster.
only. If it is not port, that means that application exposed outside the cluster. So anyone can access using not port. Not port means what? It's a using not port we expose the application, and how can we access the application using static port? Sorry, static port. For example, for that not port service, we opened 3,000 to 32,000. Sorry, 30,000 to 32,767 port number, right? So we can access the specific application through node port with one of the port number. Okay, for example, in real world, how we accessing? Taking that specific node. Okay, this is easy to write. EC2 IP, public IP. Then the port
Okay.
number, any of the port number that assigned for that specific application. Like in between these, okay, like 30,001 or 30,002, like that. So that much application we can deploy, around 2,000 something application also we can expose using not for service, because not that much static, port number are allocated for exposing application.
Got it.
So in my case, I already created the security group. Okay, I will show you. We can create a security group before deploying machine or launching machine. And whenever we launching, we need to assign the security group. That's fine. See the master. This is a master worker also there. So these all the port I opened. See, 2323. Yeah, this is fine. I'm going to set up the master machine. Okay, master. So coming to Kubernetes, okay, we need to set up the machine configuration. That is, at least we need to set as T2 medium, okay. Otherwise, it's not, I mean, a cluster will hang. And here you can see security group. By default, it's going to create a new security group, okay, if we go like this. But in this case, we have a security group. So select existing security group and drop down. So we can see the security group that we created. Hmm. Okay. I created a these two security group under the VPC DevOps learning. Okay, that's why it's not listing. Before we used another VPC, so now it's listed here. So I'm selecting the master. That's fine. I use 15 GB storage. Okay, by default 8 GB there, and launch this instance. That's fine. Same way we need to set up the master machine. Sorry, this is for master, and we need to set up for one machine for worker as well. For worker, we can go with the micro, that's fine. But that's depend on the application, okay. In real world scenario, we need to select corresponding high level machine because all the application belongs to the specific node or the specific EC2 machine. So I will go with the same T2 medium for the second machine as well. I mean the master. Sorry, worker. And here we need to select worker, okay. I have a worker security group as well. So I opened the same port number, okay, that I show you. I will share that port number detail. So this is fine. Storage also it is fine. And launch. So here we need to change to enable public AP. Launch. The two machine is created with the corresponding port number. So master and worker. So now we need to run or we need to install some components. Okay. So log into the master. some scripts are there. Okay, so we need to run some script to make master and worker. First, we need to update the package manager. Then we need to run the script. So I will show the script. Okay. Mm, I am going to create a bash script. Okay. So coming to bash, we need to, I will show that entire script. Give me a second. So this is the script. Okay. You can see my screen, right? So this is the script that we need to run master machine and worker machine. Got it. So here you can see the main part coming to the script. These are different commands. Okay, this is for disabling swap to that specific machine. Then this is another command that we need to run. Okay, if we go with the manual way, we need to run each commands, right? So the third command look like this, and fourth one, then fifth one, sixth one, seventh one, eighth one. Like you can see the sudo. That's all. Different commands. Okay. Also here we need to install CRIO runtime for that container. Kubernetes container part, we use CRIO runtime and the package key we need to download from this package. Again, we need to update package manager, install CRIO. Above we taken that package, right? So we need to run that using apt install. Then we need to restart the service daemon, enable CRIO. The service CRIO we need to start. This is for Kubernetes apt repository and install required packages. So this is for the key and the package as well. Packages. Then write something. See using T command, write something to the path Kubernetes list. Then again kubectl apt install. Then installing kubelet, kubectl, kubeadm. So these are the services. Okay, kubelet, kubectl, and kubeadm. And again update, then enable kubelet and start kubelet. So these are all the commands that we need to run in both worker machine and master machine. But I will go with create a simple script file. Okay, so inside the script file, we need to include all these commands and we can run this file only. Okay, so the file will install every components that we define in the script. So I'm going to create a script common. We need to make the extension as such. Okay, hit enter and paste that entire code here. Save and exit. ls. See that now the file has been here. Now we need to make this file as executable file, okay? Otherwise the script file is not running. So using chmod, we can make it executable. The file name. Let's see, now it's executable, right? So we can run the file using ./ the file name .sh. So it will automatically install everything. You don't bother about anything. Now do the same for the worker machine as well. Okay, here all the components are installed. See. Now we need to do the same for the worker machine as well. Okay, after running these all that commands in master node and worker node, we need to run some more commands. Okay, that's only needs to run on master part. So these are the commands we need to run in on master part. So this is actually pull the image. Okay, kubeadm image it will pull. Then I told you that's a we use the tool to bootstrapping this cluster using kubeadm. So we need to run the kubeadm tool image, and we need to init the kubeadm in our local machine. Okay. Then we need to make a directory like kube. Then using copy, we moved that configuration file. Okay, Kubernetes admin config to the same directory above we created. Okay, this one. So copy that admin.config. Then ownership, change the ownership. Then after the last command, okay, the last command we can run Kubernetes application, okay, using kubectl. So here you can see using kubectl, we install network plugin. That means Calico, okay, different types of network plugins are there. So in this case, it's downloading network plugin Calico using kubectl. So there is a Calico YAML file there. So it will run and apply. So this is the way we can run YAML manifest. Okay, the YAML manifest belongs to some remote repository. Okay, so we need to define that YAML manifest URL there using kubectl apply file. Define the file. If the file belongs to local machine, we can define that, or else it belongs to any URL like this. We need to define the ender URL. So the last URL you can see calico.yaml. So it will looking that YAML file and apply. I mean, create that network plugin. The last command, kube ADM token create print join command. So this will create a token, a API token, okay, and we need to copy that join command. This is called a join command. So we will get a joining token. So copy the joining token and paste it on worker machine. So that worker machine will a part of this master machine. So the worker also, we completed that part. Now I'm going to run that remaining commands. So this is the remaining one, okay. So I'm not making any script file, just running this one on master only, okay. This is running on master only. So now you can see it's pulling image for the master components using kubeadm. So the kube server, kube controller, kube scheduler. Everything is completed. See, now we can run kubectl command as well. Kubectl get node. See, this is a same worker machine. Okay, sorry, the master machine detail. The role we can see that is control plane. That control plane means master part. So the status now it's ready. Okay, everything seems good. Kubectl get ns for the namespace. Everything is fine. Get port. No resource fund. Get SVC. We can see the Kubernetes. Yeah. So the master part is done, but there is no worker node, right? See, only this is a master actually. Master part we can see whenever we using kubectl get node. This is actually the same mission. See the IP 10.0.031, same IP. Now we need to add that worker to this master. Okay, so just this is a token actually, print token. Okay, so this is a print token. So copy the print token and paste it on that worker machine. So it will automatically join to this Kubernetes master part or the control plane. So paste it here, hit enter. Yeah, it's completed. Now we can run it again, kubectl get node. See, the second machine joined. Status is not ready, it will take some time. Yeah, both are ready. There is no role defined here, okay? So we can define role as well. So now it's labeled. See, label as worker. Got it. This way we set up in like self-hosted Kubernetes cluster. So we can deploy any of the application. Okay, so I will check some YAML manifest. So anyone have any doubt?
So it cannot be used on like production server, right? We're going to use it for the development
Um,
purpose.
right. For
Self-host.
we don't use for the complex application as well.
Okay. How about a Minikube? Can we make use of Minikube instead of KubeADM since it is used for development?
No. Minikube is fully for learning purpose and for test application. Not good for development as well because tomorrow I will show you how to leverage a Minikube. We can run Minikube in a single machine.
Okay. So we can make use of KubeADM for simple machines for
Minikube.
production too.
No.
Do companies really use this uh, for development
Self-hosted.
self-hosting?
Yes. Companies for the development phase, actually, we can use self-hosted. Self-hosted is it's a lot of efforts are there. Okay,
Agree. We have
for
to run a
example,
lot of. Yeah. Mhm.
yes, not running actually managing the master part is crucial. So if
Setting
any
up
issues
everything.
happen, yeah, we need to check it on like that. If it is a manager one, we don't bother about the master part, right?
Agree. It's just a simple one command to.
Right. Okay, I will take some application sample. Service.yaml. So first we need to came here the master part and create the YAML file. Okay. Yeah, this is a master machine where we are working. Okay. Nano deployment YAML. Now for the same we need to take that service.yaml, write that service.yaml nano. So this will be the service.yaml for the same. Okay. So here you can see the target type. Service type is non-port. And the target port 3000. That is a container port number. Okay. And here the node port for the specific application, we use the port number, a static port number that is 30,080. This way we defining the port number when selecting the type as node port. Now we can apply. Okay, one is up and running. Second one, we face some issues. See,
Error image
ima-
pull.
error image pull. So how we will troubleshoot kubectl logs?
Oh, logs. Okay. Failed to parse source map from.
This is related to the application actually. Check again. Yeah, now it's fine.
It's running. Yeah.
Yeah. Now we need to write a service YAML for same. Now you can see only Kubernetes there. We have created that service, so we need to apply kubectl apply. Service created. See. So it's the same application. We created a service that is name. So yeah, the type is not port. And here we can see the port number as well, 30080. So how we will access the application using not port? Go to the master worker machine and copy the public IP. Actually, the application belongs to this machine, right? See, kubectl git port 005. So this is a two container in our Kubernetes cluster, and this is the IP for that specific port and which node that specific port belongs. That is 147. This is IP. So we can check this is IP of the worker machine. If we have more node, okay, I mean more worker node, we need to do the same. Like we need to set up another EC2 machine and run this command, then copy the join token like this, and that will be the second machine here for the worker. So we have a Kubernetes cluster with the two node. And for accessing the application, we need to paste the IP, public IP of that node, worker node, then copy, paste, define the port number. That is a port number 30080. Okay. 30080. I don't know. I can access this one. Can you check anyone? I put it
Yes.
on, paste it on that. It's
Yes, I
accessible,
can.
right? Yes, I can also access
It
using
works.
my
It
mobile.
works.
Yeah. So this is the way we accessing application using not port. So if we have any another application, that application using another port number, okay, in between 30,000 and 32,767.
Instead of 30,080, we can give whatever the number from 3, that
Yes,
range
yes,
to,
yes.
right?
Yes, just open the YAML manifest. Okay, main service. So I'm changing to 80 to 81. For any number, we can specify in between 30,000 and 32,000 like that. So just I'm changing to 32,000. Okay, save and exit. The same time it's applied. We'll check. I think we need to apply manually. Yes. Yeah, you can see here it's configured. That means we changed something in that service file. Can you reload with the 32,000, the port number?
Let me.
Now it's not loading, right? Or remove the cache.
Yeah, it is accessible.
Yes. Now we remove the previous port number. Got it. So any of the port number we can take like and expose the application. That's not a problem because that 2000 something port number for exposing application. That's the static port number of the node actually, the worker node for the
So
specific application. For this specific application, the static port number is 32,000. That's not changed actually.
Mhm. So in case if this node goes down, right,
Hmm.
how does it gonna work? It's gonna assign a different IP address, right? We cannot access
Different IP address in the sense of
I- deployment. If
um
we give a
uh,
replica,
yeah, got it. So this IP, right? Public IP.
uh-huh.
In that case, we need to set up, I mean, the troubleshoot or what IP the specific application. I will try to reload that application. Okay, sorry, reload the node and we can check restart.
Okay.
Successfully initiated that. Can anyone check that application? 32,000.
It's not working.
Yes. See the container creation.
Mhm.
Since the application is belongs to Kubernetes, we don't need anything. Okay, the container will automatically restart. It will take some time. That's all. See, now it's loaded. You can refresh that.
Okay.
You can see the application. It will take some time. It's loaded, right? For me,
Yes,
it's
yes.
loaded.
Mm-hmm.
Yeah. So whenever the node restarted, okay, the container also restarted because the container belongs to that uh, node, right? Also, we don't define that part because coming to Kubernetes, the default restart policy is always. That's why the container will restart again automatically.
No, then not in case of restarting actually, when the pod is down and when we um, give replica
Yes,
set. So in case of replica set, if pod goes down, it's going to create a new one, right? Instead of rebooting the same one. So in that
right.
case, the IP will change for sure.
For this case, the IP won't change actually because
This
we
case,
just
it won't change. Yeah.
yeah,
Maybe that one we have to go with the load balancer.
right.
And is this the same like script for if we're gonna go like in future we're gonna join the job? Can we make use of the same script which you have like gone through?
Yes, yes, this is the same. That's why I told you Kubedium is a production ready tool to bootstrapping Kubernetes.
Just we need to tweak some maybe according to our requirement.
Yes.
Have you done something? I
So I
don't.
am sorry.
Have you done something? It has created two more.
Yes, I changed the replicas to
Oh,
four
replica
batch.
set. Okay.
So now we have four working port. Got it, all of you. Any doubt?
No doubts for me.
So these will belong to worker node. Is it
Which one? Which one?
this replica set?
Yeah, all of this belongs to the worker node. You can check that as well using kubectl -override. So we can see that specific ports belongs to which node. This is a node name.
Mm-hmm.
I mean, 147. That is a private IP. So that is the machine. So the worker machine, okay. The port private IP is 147.
147. Okay.
So these all the ports belongs to the node that private IP 147. So this way we identify which that specific node, which port belongs to which node using kubectl get port -o void.
Okay. Thank you.
This way we accessing the pod, okay. I mean, log into the container. Then we need to define bin bash or bin sh. See, now I am logging to the container, one of the pod, okay. Not pod actually. So these are the pods and inside the pod there's container, right? So now I am in container. So here we can see all that files. So you can see we are in a working directory that is called app.
App.
So when going to that specific application, I will show you that there is a Docker file for the same. So this is a Docker file. This is a Docker file, and here you can see set up a working directory. So this is a working directory. Now we are logging app. So whenever we log into that specific container, we are directly going inside the working directory. So it will copy the package.json file from that local machine to the container machine. Okay, so we can check that as well. Package.json. See. So this is copying from local or from that repository as well. Okay. So we need to keep that file in the repository. So whenever building, so it will copy from the repo. So this is a Node.js application. That's why here you can see the base image is Node 16 and npm to install dependencies. That dependency belongs to package or JSON file. Okay. So here we can see package.json. So inside this file, cat package.json. They mentioned the dependencies and everything. So it will download whenever the build process start. I mean the Docker build. Okay. Then run the React application. Then this for the copy entire rest of the application code. Okay. So they use the copy instruction and the first dot for the host and the second host dot for the container. So it will copy all that file and move to host to the container. And above you can see specify the file name. That's all. So this is a file name and it will copy the root path. That means that where the app directory app belongs. Okay. Inside root we can see the app. And container port, then the CMD. It will start npm whenever the container start. So this way we log into Kubernetes container, okay, using kubectl ex command, then the kind of port name, then the mode that we need to log in. So here I'm using bin as such. Got it. Anyone have a doubt?
I'm
Or
good.
else we can wind up pretty second, right?
Yeah.
Then tomorrow we can go with the mini cube, okay?
Okay.
Okay. Thank you for the
Yeah.
class. Have a good morning, Tawfiq sir. Good night, everybody else.
Bye.
Bye.
Bye all.